All right, let's look at how to actually figure out the configuration of the molecule, whether this is R or S. And in my previous video, I talked about the perfect orientation of how the molecule should look like before you start numbering them to determine whether they are R or S, okay? And now in this one, we will actually carry out the whole process to determine whether this is R or S, all right? So in the first step, we'll number the atoms or substituents. So in this molecule, what we see is actually chlorine is the highest molecular mass, and that's why that gets the number 1. And the numbering is given according to molecular masses, right? So chlorine is number 1. So it got the first priority, followed by oxygen, which is number 2, because that has the lesser molecular mass compared to chlorine, followed by carbon, and followed by hydrogen, which is the lowest molecular mass, right? So what we have seen in the previous video is that if your lowest molecular mass is behind the plane, or it's going away from you, or it's on the dash bond, that's the perfect orientation of the molecule that you want before you actually start determining R or S. Okay, so now we see that this is the perfect configuration because H, which is the lowest molecular mass substituent, is on the dash. And that's what we wanted before we proceeded, okay? And now what you want to do is use an arrow to follow the numbers. So we'll follow 1 to 2 to 3, okay? And draw out the arrow. And if this arrow goes anti-clockwise, the configuration is S. So we're going anti right now, right? In an anti-clockwise direction. So that carbon right over here, right? This carbon is an S carbon. The stereochemistry of that carbon is S. Okay. And if we see that it goes clockwise, the stereochemistry would be R. Straightforward, right? Number your substituents, follow the arrow going from 1 to 2 to 3, and then forget about the fourth substituent, provided the fourth is on the dash bond. And the third step, connect your atoms going from 1 to 2 to 3. If it's anti-clockwise, it is S, okay? And if it is clockwise, it is R. Straightforward, right? Now let's look at another example. Okay, and in this example, what we really see here is that the H, which is the lowest molecular mass, instead is now facing towards me and not away from me. And this is not an ideal orientation. So to make it an ideal orientation, we have to move around the atoms such that the H would end up being on the dash, okay? And in order to do that, what we have to do is, the first step would be this time, switch over 2 pairs of atoms, okay? So 2 is important here because if you switch over 1 pair of atoms, it's gonna change the answer of the molecule. It's going to change the stereochemistry of the molecule, and you don't want to do that. You want to keep the stereochemistry the same, okay? And in order to do that, we'll switch over 2 pairs, and it will keep the stereochemistry unaffected. And what we mean by switching over 2 pairs of atoms, let's actually look at that. Let's actually switch them over. So the first thing again, I'm gonna number them 1, 2, 3, 4, right? And now I'm switching over HNCl, okay? And what it actually looks like is that now in the front I get ACl, and in the back I would have the H. This is what I have after making my first switch. Okay, and now let's make the second switch. So the point of making my switches is that the lowest priority should end up on the dash bond, or to get the perfect orientation to determine whether the compound is R or S. Okay, and now switching over the second pair between OH and CH3, I'm going to switch over OH and CH3. It can be anything, literally anything. You can switch over anything. It does not matter. You just want to make sure that in the end, the H or the lowest molecular atom or group or your substituent, all the same names for the same connectivity, it should end up at dash bond. Cool? Now, once that has happened, okay, let's switch them over. Okay, now once that has happened, two switches have taken place, and now you can do the numbering and figure out whether this is R or S. And let's do that now really quick. Again, Cl is 1, OH is 2, C is 3, and the fourth is your hydrogen. Now follow the numbers going from 1 to 2 to 3. We're going clockwise, right? We're going clockwise, and that is R. Going clockwise is R. So what we essentially see here is that if you switch over the stereochemistry, or if you see that the desired substituent, which is the lowest priority, if it is on your wedge instead of your dash, or you can say that they're in the opposite configuration than the one that you wanted, in that situation, reverse your rules. And what I mean by that is, if you see the lowest priority on wedge instead of on the dash, going clockwise would become S, and going anti-clockwise would become an R, and you wouldn't have to switch over two pairs before you can get the answer. What I mean by that is, you have the numbering of the molecule, right, as it is. Just follow the numbers. You get some, if I'm following the numbers with the arrow in the structure represented above, before I did any of the switches, if I try to figure out whether this is R or S in the original structure, so what do I get? 1, 2, 3, following 1, 2, 3, I'm going anti-clockwise, right? Anti-clockwise is generally, usually S, right? But in this scenario, it's going to be R, because H is on the opposite bond, right? So whenever you get the opposite bond situation, you can make your rules the opposite rules, kind of. Okay. Now let's look at another situation. Again, not a very ideal situation, right? Because what we essentially see here is the H, or the lowest priority bond, lowest priority group on the plane bond, not above the plane, below the plane, not on wedge or dash. It's in the plane bond. And when that happens, there is no other trick. There is no other way to figure out. You cannot switch over the rules. There's nothing that's possible. You have to do the exchanges of two pairs. And let's do that really quick here. So in the first step, I'm going to choose H and Cl, because I want my H in the first step and ending up on my dash bond, right? So now in the first step, H has ended up on my dash bond, and Cl has ended up here. CH3 and OH. Okay, and now let's do that again, because we need to do that twice, right? So again, now I'm going to switch over Cl and H. I just don't want to switch over my H now. I want it to stay unaffected because I want it on my dash bond. So I'm going to switch over Cl and CH3, but at this point, it can be any two atoms you can switch over. It does not really matter, okay? Okay, once now we have the ideal configuration, right? What we see again is H at the dash bond, ideal situation, start numbering them, follow the arrow, clockwise R, anti-clockwise S. Okay, and now what we get again is Cl number 1, OH number 2, carbon number 3, hydrogen number 4, follow the arrows going from 1 to 2 to 3. We are going in an anti-clockwise direction, right? Anti-clockwise direction is S. So this compound has an S stereochemistry. Cool. All right, and now I'm gonna see you guys next time. Have a great rest of your day in the meantime.